It starts with a 2-hour download for a massive 60-gigabyte model that crushed the latest coding benchmarks. But the moment you load it up and type a prompt, your local machine completely chokes. Academic leaderboards measure these models in sterilized, cloud-hosted environments. They rely on unlimited memory and full precision weights that most developers simply don't have access to at home. Running these same models on local hardware introduces a different set of rules. You're working with quantized weights and a strict memory budget. When the data requirements exceed those limits, the performance gains seen on a leaderboard vanish as your system grinds to a halt. Coding efficiency depends on finding the highest accuracy your specific hardware can actually sustain without crashing. The hard limit for local deployment is your GPU's video RAM, or VRAM. Attempting to run a 70 billion parameter model like Llama 3 on a consumer graphics card quickly exhausts that available space. To prevent a total crash, your system diverts the overflow into your standard system RAM. Because system RAM is significantly slower, your generation speed plummets from a snappy interactive pace to less than 2 tokens per second. At that speed, a simple request for a React component takes several minutes. The model stops being an assistant and becomes a background batch processor. VRAM acts as the primary filter for local AI. If the model doesn't fit the memory, the coding quality is irrelevant. For developers on the 12-gigabyte consumer tier, like those using an RTX 3060, the options are limited by this memory wall. Heavy models like Mistral Large 2 stay trapped in the red zone, unusable for live coding. In contrast, Llama 3 8B and Llama 2 9B shoot well past 28 tokens per second, providing speed for real-time work. Speed comes at the cost of reasoning. Using a model under 10 billion parameters means the AI will struggle with complex multi-step logical chains. Llama 2 9B, for example, often fails to properly route asynchronous middleware in Node.js, leading to code that silently swallows errors. If you are restricted to a 12-gigabyte card, prioritizing raw speed and memory fit is the only way to maintain a functional workflow. If you've upgraded to a 24-gigabyte card like the RTX 4090, you have the headroom required for significantly more complex models. Llama 3 70B stands as the primary recommendation for Python-heavy development on this hardware. It hits 74. For developers who need precise Python syntax and robust error handling, the higher accuracy of the 70B model justifies its slower pace. JavaScript development brings a different set of requirements, particularly when building modern React components or Express API endpoints. MiniMax 2.5 is the current leader for these tasks. It excels at generating modern, functional React components with correct hook usage. You should watch for deprecated middleware in its outputs, and keep in mind that its architecture requires nearly 18 gigabytes of VRAM. If your focus is Node.js and you need flawless API structure, Mistral Large 2 is the heavy-duty alternative. Mistral shows the highest competence in executing complex SOD schema validations and generating structured JSON. However, Mistral Large 2 requires over 72 gigabytes of VRAM. For most, this makes it an offline batch processing tool rather than a real-time assistant. Your choice of language changes the rankings. A model that wins in Python can easily stumble when faced with modern React code. Finding the right local model involves a systematic look at how your hardware limits your software options. If your GPU has a 12-gigabyte ceiling, you should deploy Llama 2 9B or Llama 3 8B. These lightweight models ensure your coding speed stays snappy and interactive, even if you lose some depth in complex logic. If you have 24 gigabytes or more of VRAM, your choice depends on your primary programming language. For Python-heavy projects, Llama 3 70B provides the most reliable standard library accuracy and edge case handling. JavaScript and React developers should choose MiniMax 2.5, provided their hardware can support its 18-gigabyte footprint. For high-end API development and tool use, Mistral Large 2 offers the most structured output, if you have the massive hardware required to run it. A successful local setup requires an equilibrium between model capability, your language stack, and the uncompromising physical boundaries of your machine.